Okay, so let me share my screen so that you can be able to see everything. I hope that you can be able to send messages into the chat, or you can unmute and ask questions if there are any, or contribute. So from yesterday, I hope that now you're able to open the software, and then I hope that you realize that Prota Structure says. So when you have, for example, when you go to your computer, let me just open a folder. Here, when you go to your, for example, this PC, for me, I do not, I only have one file, one disk. I haven't partitioned it. And then this is my external hard, this is my USB. So when you go into your local disk C, here in, I think it should be program files, isn't it? Actually, no, it's here. Yeah, because I have 2018, 2021, and 2022. We've been using 2018. When you click, when you enter this folder, oh, sorry, it's actually in the documents. So here, when you go to your documents there, you should see something like Prota 2018 here. You click on it and it displays all the files. And you can actually have more files into other files, right? So here, this is what we wish this is what we wish to arrive at. Like I did some analysis. I added some traces here, and you can see that it shows that some of the members are okay, they're in green. Actually, this one I did it with obedience, so some of the members are okay, and then others need to be worked on. For example, the purlins on this side, the C channels, you can see that they are green. And when you hover your mouse over them, it shows that it's 150 by 90 by 24. And it also says the material is S355. Meanwhile, when you go to this other side, I use the same method and I use the same material, but it's saying it's in red, it's spelled. So it probably requires some steel member design, changing the, and yeah. So in order for steel, it's different to concrete. So when you select, you go to your steel member design. It shows you that it shows you where the problem is. So this one is saying the slenderness, and this is partly because I placed it. It's running from, actually it's split. I wasn't placing it in sections. I selected from there all the way to there. Meanwhile, this is okay. This one isn't, right? And then also inside there you can see I've got a little some beams that are red and others aren't. So let's open the one that we've been working on. I'll go to my file. I'll say open project. I know it's in the other, this one here. And then I'll click on it. Find project. Okay, before I do that, let me just make sure that I save. Okay, save. And then open project. This one here. Okay. Yes. So now guys, you can see from yesterday we added another level, flow level, right? And then we also learned how we can be able to see in the level that we have or the flow that we have if we populated that area. Because as a disclaimer, remember I said you can only be able to run an analysis if all the flows and the levels are populated or they've got information in them. So when you go to building setout here, you go to your edit story, you've got these check boxes here for information, right? So it shows which one of your flows is populated. And then, so bear in mind, right now we only have the ground floor, the ground level, and the wall plate. The wall plate was taking the columns to the ground floor, and the ground floor has got those concrete columns that are the stubs. There's nothing on the ring beam, and I really don't think we will need the ring beam. And also, there's nothing on the roof apex. This is one way in which you can check if floor is populated. The other way, you would have to go to the, you can check each plan view. For example, here I'll go to the 00. This is the foundation. It's reading from beneath. And then the ground floor, same information as you can see. The ring beam has no information. Similar to the edit story function, that one. The first floor, nothing. The wall plate has got these trusses and these steel columns. The roof has nothing. Okay. So now, I don't know whether certain things have changed to this drawing. So I don't know whether we should make those changes or we just do what we can and run an analysis. What do you guys suggest? Because we've been modeling for quite a long time. So how many people are in the chat today? We've got two, but two won't be unanimous. You need about three. Eh, Niza Mukubesa, what do you guys think? Should we change
What
according?
what did you ask?
So certain information has changed. This drawing has changed. So should we make those changes accordingly, or should we run an analysis today?
I think maybe we should make the changes. Is it
Okay.
going to take very long?
It may. It may. Okay, let me show you. Did I download that image? I think if the changes, I think I did. I may have. Let me see. On the desktop here, here, images. No. Okay, let me get the image. Okay, can you guys see my screen?
No, can't see your screen.
Okay, and now? So this is how the drawing has changed now.
Nope. Oh yeah, no, I can.
So let me just show you where the major changes are. I'll put them side by side, and then I'll go to the ground floor. So you can see that the previous drawing had 26 columns. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You see? The drawing that we've been working on had 26. But then, according to the changes, now we have 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And so, anyway, let's quickly just make these changes and then we'll see. So for example, here on axis 2, here we have another column. So what we can do is we click on properties, and then we'll be creating something similar there. Where else? At B. So this one, pardon? This one actually, yeah, so this one actually, the name changes now. This should be C. Oh, yeah. Yeah, it's okay, yeah. So place another column there, and then this one is okay, but this one we remove it. We delete, okay, and also the axis. Oh, there's a column underscore 44. Let me check this one. Select, delete, plan view. This one remains, right? Should be up to N now. Here it has, which one is it? A, B, C, D, A, B, C, D, it remains. Oh, this is where the two are. This one and this one. Eh, I just can't. Actually, I can go in and rename them now. So this is A, B, C, D. This should be E. So to rename, you select it, you click properties, you change in the label, and then you give it the name that you wish. Properties, label, this is F now. Update, close. This is G. Properties, like that, close. H. So I'll be sharing this image. In fact, I'll share a better one. I'll be sharing this image in the WhatsApp group just for you to follow. Okay, I've shared it in the group. So G and H has, so this changes to I, right? I only has one single. Someone say something like this. I'm trying to log in Teams for password. As soon as I can change it. Ah, use the, you need to use the web. So we've got G, H, this is I. After I, we've got J. So change it to J, and then we need another column here, right? And then this one is redundant. This one is the one that was deleted, isn't it? Like before, there's There's a still column on it. Delete it. Go back to my plan view. You save. Okay. I'll just replying to some messages. So after I, J, it should be K, capital K, operator, L, L has a column also, doesn't it, sir? L, M only has one, and then N has three. Okay. Alright, so we've made the changes now. And then we need to calculate the midpoint. Oh, okay. So now let's look at the way that it looks now. This is a better system. The one from before wasn't very good. So now we have this system, and then we need to place more columns here. So how we're going to do that is we'll create another floor. Actually, this one is the one that needs to change. This one will be maintained. So this is on the fourth level. So we go to more plates. We change the plan view, and then we'll be able to place some columns on the new columns that we've just created. So here on A2 has one, then C also has one, E has one here, G also has one, and H, they're existing already. J has one, L has one, and then N also has one. Let's have a look and see how that looks like in 3D, just like that. G and H, okay. So this is good. So now we need to change our truss now, our truss system. In order for it to look like the sample section here, because now we want the top to be like that. So now the truss will only rest on here and here. This is 1, and this is 2, and this is 3. So now we change our truss system. I hope you guys are following me. So I'll delete this. In fact, I'll delete all of them. An easier way, you can do that in 3D, or you can go to your plan view, and then you can filter and select and delete everything at once. Okay, so now I can go into my, I'll be placing them on the wall plate, right? I go to my wall plate level, I'm already on the wall plate. Change to, also already on the, change to plan view, and then go to my steel member, steel truss. Uh, from there to there, I'll choose this one, and then I'll change this to 0 and this to 0, and then I'll change my members also, top and bottom code. I'll use an IP 200, 140, let me use 140, or maybe 160 for my top codes. For my bottom code, I'll use a 200, and then everything else will remain as is. So from there on, we can copy there and here, and this is already some of the things that we've done. So that's why I'm rushing it. You see, like that, because I'm really hoping to do a structure analysis today, like that. And then I'll press escape to come out of the command, and then I'll change to 3D, and now you can see that we have something that's looking like what we have here in the PDF. Okay, so now what this means is that this column, now we need to remove it, or we can change the top, give it a top offset. But if we give it a top offset, it means it's still on the wall plate. Remember that problem that we had? So it means it's still on the wall plate. So what we need to do is we need to create another level that we can call canopy. For example, this is the Revit file that I've done this in Prota. I've also done it in Revit. So if you look at my maybe west elevation here, you can see that I have a canopy level here, which is 3 meters above the first floor, and then 1 meter there, and then 1959. So what we can do is we can I'll delete all of these, and remember they're on the wall plate, right? So change to plan wall plate. Remember they're the ones on 3, on axis 3. So I'll just filter out, select my column, and then I'll draw a square like that. Select all the bottom ones. Prompts me, asks me what I wish to delete. I'll delete the columns, select it, deselect the filter. Okay, let me just save. Good practice to save. You never know, power my cut. So if we go back to the 3D view here, we can see that we've deleted those columns and we're only remaining with the stubs, right? So now we need to create, where do we need to, yeah, but which story do we need to create? Remember what Prota does, it shifts. What does it do? You remember from yesterday? Okay, so how about we create a floor on the first floor, right? It pushes it, right? Let's confirm. So for example, when I right click and say add a story at this level, it says this and previous processes will not be undone after this step. Do you want to continue? Say yes. So it says a new story will be added by shifting the existing levels upwards. So the wall plate, right? So that it can shift upwards. So we'll go to the wall plate here. There's already a wall plate. Hmm? This is for the roof. So we'll add a story on this. Let's see. And lo and behold, we have 2 wall plates, right? Okay, so how do we overcome this issue? There's something that's extremely excessive. We go to the building setout. So what this means is that at first we had, in fact, I do not even need the ring beam, guys. I'll delete it. So let me just go there and delete this store information. Delete the store information doesn't remove the store. Okay, now the ring beam has been removed. And if we go to building setout, let's see. All but the first floor wall plate and this other wall plate haven't been populated. On the first floor, we'll put some beams and also some slabs. But then, oh, let's go to the building setout again. The edit story. So here we have the 200 for the stub, and then you see the difference in elevation. I do not need for this to be 1 1. So it needs to be 400 also, right? Okay. There's a network issue. Oh, the internet. Uh, mm, yeah. Okay. Just hotspot using my computer. I need to refresh this. What one is it? Let's go to a new thing. Yeah. So what we'll do is we'll change this to be to also have 4 meters, right? So here, if I say 4 meters, yes, then the wall plate will go up another 4 meters also. But then the canopy, I need it to only be 3,000, right? According to this distance here. And then, so this I need to, which one do I need to change? This I need, actually this is the canopy. Okay. Um, so we're still on the edit story here. So from the ground floor to the first floor, I need the height to be 4 meters. And then from the first floor to the canopy, I need it to be 3 meters. Just this side, because this will be like the corridor. I do not need for the height to be so high. So this will be 3,000, and then I'll call it canopy, right? And then from the canopy to the wall plate, it's only going to be 1,000, meaning the canopy plus the wall plate is 4,000 in total. And then does that give 8,200 here also? Yeah, 8,200 plus that 200. And then this one will be 15 what? 1595. Okay, and then there. Mind you, let me put this to 0 because initially we had given it an base of 6, right? But if I put it on 0 like that, it will guide me and tell me how much I need to go down. Okay. So I know, and for everyone else who's been having problems with this, like before, like the way that I used to have problems with it, I'll go to the story. So it's telling me from the wall plate, it's going to the canopy. So it's just reducing by 1,000, right? But then from 7,200 to 200, I need to go to the ground floor. I need 7,000, right? This minus that. And therefore, I'll click it, right click, properties, and then I'll say minus 7,000, and then I'll update and close. And for sure, yeah, right on. So that I do not waste a lot of time, I know exactly what I need to do. I need to go to the workplace level in my 2D, in my plan view, and then I need to filter, right? And then select all my columns, and then right click, properties, brings me to the column table. And I need to change all of them to minus 7,000, right? And then enter, close, deselect this, change to my 3D, and there, you see, I'll control save it. So now what we are going to have is this situation of now placing I had a piece of paper here where I had drawn, is it this one? I think it's my 7 and 9. Okay, so now I need to go to my canopy level so that I can place the other columns, right? Go to my plan view. But first, just to confirm, I'm using 254, 254, and 167 there, right? So I'll go to my canopy, change 2D. I do not necessarily need to click on the column concrete, the concrete column. I can directly go to the steel member there.
I think I can see your screen.
Oh, you cannot see the screen. Oh,
Uh,
guys, it took you that long, guys. Can you see it now?
Not yet.
Really? Okay, let me stop sharing and share again.
No, I do.
Oh, it was lagging.
I started seeing it.
It was lagging. It was behind. Okay,
Uh,
okay. I'm pretty sure you'll be able to see it now. So now I'll be placing columns from the canopy level, and I need my. Oh, that's a beam. And steel column. Let's see if it maintains. What size is it? I'll insert it here. Yeah, it maintains the 254, 254. And then I'll go there. It's everywhere, right? Yeah. And there, and there. Okay, I'll press everywhere. And then if I notice that there's a discrepancy somewhere, I'll go in my 3D and delete it. There, and there, and there, and there, and there. Okay. See, there's a message in the WhatsApp group that says some of us will survive to the same life. Oh, okay. So we go to a 3D. Yeah. So now the top offset is exactly where we need it to be. However, the bottom offset isn't, right? It's going way beyond. So what we'll do is, yeah, we'll put it at 0, go to 3D, just so we can be able to carry out the math. Close. So from canopy to first floor, it's about 3,000, isn't it? Let's confirm. From here, from the canopy to the first floor, it's 72 minus 42, which is 3. So now it's going to be 3,000 minus 200, which is what? 4, 8, 28. 28. So we'll go to plan view, filter, right? And then select the column. And then right click, properties, minus 2,800. There, let's see. Let's see if what we've done is the correct thing. Oh, there's a problem coming. Did we carry out the math properly? Let's try again. It's coming from the canopy, 10,200. 10,200. And it's going on the first floor. And the first floor is 4,200. 3,000 minus 200. Yeah, it's supposed to be 2. So then where is the problem? Let's see. Hmm. Let's see. Just to confirm. This is the raw plate. And then this is the canopy. And then that's the first floor. Then we're going to give it a dot. Or let me give it a 0 again. And check where it falls. Yeah. So 72 minus, yeah, canopy is the same thing. Minus 3. Oh, 10,200 minus 3,000, 4,200. 4,200 minus 200, 4,000. Let's try the 4,000. Click minus 4,000. Yep, so this is correct. So need to repeat what I just did there. I'll go to my canopy level and then I'll select filter, select the columns like that. Right click, properties, brings us to the column table. Select minus 4,000, enter, close, and then we select, switch to 3D, and there we have this uh, structure now, right? Control S. Okay. So now we can place the little trusses for the canopy, and we'll place it. Okay, let's see how many floors have we populated right now. All but the first floor and the roof. What are we going to put on the roof? Okay. So here I go to my plan view and then I go to my canopy level. I'll be placing some trusses.
Is it just me? I can't see a screen.
It's sharing the screen. Can anyone else confirm that they cannot see the screen? Okay. No, it is. It's sharing. Okay. So I'll be placing another truss, but this time this one will be like a half truss. So I'll select from here to here, but this is not the kind that I wish. I wish to use this one, and then I would like this side, the HL, to be higher, and I would like this one to be lower, right? And so therefore, I'll change my HL to be 1,000, and then I'll put this one to be 0. You see? But then there are certain members that I need to delete. You see these, they do not look so good. So I'll go to members. For my diagonal, I'll try to delete my 8. So you select it and you delete it. But let me just zoom in so that I make sure that I'm deleting the right ones. There. So one went. Let's see. 8 and 9. The other one went. So the diagonals have gone. But then for, let's see, I'll say 8. The 8 went. How about the 7? Also the 7 went. Which other one do I need to delete? This one doesn't seem as if it's 7 on purpose. Could it be number 9 of the other ones? So the other one, isn't it? See, yeah. So now I've got something that I like. This can be cut later on when you're doing your design. So now it's on every. Let's see. Someone's trying to join. Okay. So there and 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 there, 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 and there. Okay, let's change this to 3D. See if we. Yeah, yeah. This is exactly what we. Yeah, but here we do not need. So you go in because it cannot be cantilevered. It doesn't serve any purpose if it's cantilevered. So you delete that. You delete this also. You delete this. You delete this. I deleted the right one. I do not need this one. These two I need. This I do not need. This also I do not need. Delete. So I'm simply just I'm selecting and pressing the delete button on my keyboard. Okay. So for these columns, actually these I need them to start from the ground, from the first floor. I do not need to start them at the canopy level. So I'll need to delete them and go to my, and remember these are the ones that, okay. So I'll delete that one. I'll delete that one also. And then I'll delete this and this and this and this. And then I'll go into my ground floor, my first floor, change to plan view, and then insert this column, two column. I know it's here, and where else? Okay, I know it's at B, and then at D, at F, and then at I here, and then K and M here. press escape to come out of the command. Press on the, yeah. So my top is okay, as you can see. My top is okay, but my bottom is not. So here, I simply just need to go there and give it a 0. 0, and you can see it fits exactly. This one, control to select multiple, control, control, control. You go to the table, give it a 0 offset, press enter, close, and you have this. Yeah. And then what we can do is we can place the beams on the first floor, the edge beams and also some of the tributary beams. Okay, so we go into the plan view, then go to steel member, steel beam. You select the section. I'll be using UB, a universal beam, and I'll be using what size is that? Is it a 305? I'll be using a 533. A 533. So how you select your beams is through, you have to carry out certain calculations according to the load beam. According to the, is it 1.4, 1.2? Yeah, and also you calculate self-imposed load, and then you can be, maybe we can do that in a later video. But I can show you how you can select your beam. And, yeah, yeah, the beam section. And also, most importantly, here we have very long spans. This is like a general um, a rule of thumb, because we've got the longest span is about 11.7, right? And so you do not want a thin beam, because deflection, it will bend according to the WL squared over 8 formula, that one, or the QL squared over 8. You're going to, when you draw a bending moment, you'll see that it's going to deflect. So you need one that's really deep. So the 533, 160, 165, and actually 210. 533, 210, and 109, right? Is it? And 82? Okay, this one. You select, you okay. And then, so the first beam is spanning from here to there. And then the other one spans even longer. This is the 11 point, the 11.7 span I was talking about, from C to E, like that. And then from E to G, because these middle parts do not have any support, like that. And then from G to H, this one is the symmetry point, like that. And then from H to J, like that. And then from J to L, like that. And then from L to N. So here we were skipping one. Let's see how that looks like in 3D. So this is what you've done. The edges are deep because although there's an axis here, there's no support. Although there's a grid line M, there's nothing to hold up our beam. And so therefore it really needs to be deep, right? Where else can we use? Since when you pay attention, this is like one structure. From 1 to 2, 1 to 2 is like a separate structure. So I add more beams here. I'll go to my plan view. I do not need to use the steel member option. I can simply click the one that I intend to use, right click, properties, and then from there to there. Okay, and then similar from there to there, there to there. We're skipping one, there to there, up until you reach this point where you do not skip. Then from there to there, there to there, there to there, and around again. So we've got a very impressive theme system now. Control S, save, and then you check your 3D, and this is what we've done, right? So I would like this also to have deeper beams. Wherever there's a truss, also I put a deep beam. I go to my plan view, and then I select, and then I'll say from there to there, from there to there, from there to there, from there to there, then from there to there, from there to there. Okay, and then I go to my 3D, and then we've got a system like this, right? And then for the outer ones, I can use smaller beams. For the outer edges, I can use smaller beams. Mind you, I need a middle axis here also, because we're going to be casting concrete. This floor will be made out of concrete, and so we need as much support to hold up the slab as we can get. So if you guys are willing, let me go another maybe 20-30 minutes, and then so that we can finish the first floor. So I'll change my beam section now. I'll use something like maybe a 254 146. So I go to my plan view, and then which direction should I choose to span first? Okay. Still member, still beam. I need a UB. I click on that beam manager, section manager. I go to my UB. I can use a 254 146 and maybe 43. 254 146 43. I okay, and then I'll use it for these smaller sections like that. Because this is going to be like a cantilever in some areas, and it's just going to be a canopy, so we do not expect a lot of loading here, except for maybe when it's recess or like that, like that, like that, like that, and then from there to there, to there, to there, there, to there, there, to there, to there, there, like that. Okay. Can switch to my 3D to check this. Okay. Now I have a beam system. You can see that these are not as big. Okay, and then I'll change my view. So right now I need to add a midpoint. Obedience, do you remember the midpoint? What's the midpoint? Let's see if I go to my 4381, right? So let's create an axis here. We'll offset minus 4381 and call it mid. Right click, sorry, you select, right click, offset, shift F2, minus 4381, like that. So I do not want it to say number 4. I would like it to say midpoint. You can either give it MP, or you can just say mid, and then you select, you update. Because these spans are too large, I'd like to add supporting columns, the smaller ones, so that I can have slab pockets. And I think maybe we can end the video by adding slabs, right? So I save it, and then I'll repeat the process of bin insertion, and then later on we can add some slabs, and then it appears as if we can carry out the analysis tomorrow. So select it, properties. I would like it to span from, this is the secondary view, to span from there to there, the smaller ones. This is a secondary beam, it's not primary. The primary ones are the ones that are really big. Okay, like that, like that, like that. Mhm, like that. And then I'll add more here, from there to there, to there, to there, to there, to there. In doing so, we'll be creating a two-way slab, so that it can have support on all of its edges. Something like that. Okay, let's see how this looks like in 3D. There. Well, so now you can see that you got larger beams and you got smaller ones. These are the primary ones on the four sides, and then in the middle you got the secondary ones. So the secondary ones will be transmitting all the loading to the primary ones, which will be transmitting to the columns, which will be transmitting to the foundations, which will be transmitting to the soil or the earth, and therefore you need a very strong bearing capacity. So you go to the first floor plan, and then you insert your slab. So you can say here on this button here, or you can go to concrete member, you select slab, or you can go to this button, whichever one suits you. So let me put this here. I'll put it here. So it says slab properties. These are the general. It gives labels of one. Slab type. Here, when you click in slab type, you've got this. This one is a one. This is a two-way. It's being supported on both sides. This is, I think, could be one way. This one, number 5, is one way. And then you've got the cantilever one here and other types. And then H is the thickness. I would like to use 150. And the concrete cover, I would like to give it something like 30, right? And I would like to be inserting right there in the middle. And then when I go to the loading, the self weight of concrete is about 3.6. The value, what are you using? What will you be using the slab for? It's going to be, well, it's not a flat roof, it's a room. And then the dead load, says 2.37. These values you can change them if you like, but these are the defaults for concrete. And then the enforced load, you right click, and then it gives you certain information. For a classroom, you probably need to use something like communal kitchens. Anything with three would suit a classroom, even these kitchen laboratories. 3.5, no, that's too much. Less than 3 would be less. So I'll choose A, communal kitchens, and then I'll start placing them there, 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 there. This one I'll leave it for accessibility, okay? And then here, 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 here. This one also I'll leave for as a staircase because we have to access the first floor one way or another. We can either have elevate stairs on the side or we can have them right here, right? So let's see how that looks like in 3D. You see? And then I'll control S, and then I can add a floor also on the ground floor, also known as the slab on grade or the foundation slab, because it rests on the earth, on the grade, hence slab on grade. So when you go to ground floor, you select it, you switch to your plan view, you select, you can add for here, since okay, so this slab on the first floor, the one that was just added, it's called a suspended slab because it's suspended in the air, right? But on the ground floor, this floor will not be suspended, it will be resting on the ground, on the grade. And so you do not need to have it as thick or as reinforced, especially if your ground has been properly compacted. So when you go to your slab option here, I do not need for it to be 150. It can even be 100, but I'm feeling generous, so I'll put it at 120. And then I can maintain the other factors. Even the loading, I can maintain it as 3, although I could reduce it if I wanted. And then I'll update, and then I'll start placing them like that. You can see that this is a two-way, although it shows the direction of two sides. Actually, this is a one-way because it doesn't have any supports on the side. And then I will not leave any accessibility because it just needs to be open on the it's on the floor. It needs to be open above and not below. If we had a floor below it, then we would need, and that's it. I exit, I control S, and then let's see. I think this could be it. I hope you guys are following. So for this, we say we go to a 3D, and you can see that we now have a slab on grade, and um, we have this first floor slab. I don't know whether we should continue by adding purlins so that we can carry out the analysis tomorrow, or we can, in fact, because tomorrow is going to be quite intense, we'll be adding loads. So let's add the purlin so that tomorrow we can just run an analysis and design the foundation. Okay. So you need the roof roofing material, whether iron sheets, whether heavy towels, whether whatever. You need them to rest onto something, or maybe timber trusses. So therefore, you need some C channels, aka purlins. So where are you going to be placing them? But let me just check that all of my floors are populated. All except okay. So I'll go to my, I need to place it. The roof will be invalidated. I don't think we need the roof. So I'll go to my wall plates. Will I be placing them on the wall plate or will I be placing them on it? Anyway, the thing with the purlins is that you go to your steel member, you select purlin, and here it says pick two trusses for inserting the member. And I'll pick this one and that one. And then you see it shows me the type of purlins it will use. And then it tells me it's going to use 100 and it's going to be using a UPFC. UPFC, I think, is short for Universal Parallel Flange Channel. Is it? I am not sure. Let's see. Should we confirm? Anyway, you can confirm it on yourselves. But I think PFC stands for, yeah, it could be Parallel Flange Channel or something like that. So I need to use, I'll use the bigger one. And you see why I need to use a bigger one, the 24. I'll show you why in a minute. So okay, and then you can see that it's increased. And then when I, here on the loading, we need to load it, but I will not load it in this video. I'll load it in the next, together with the loads for the other things like the load combinations and so on and so forth. So here I'll say yes, and then you can see that it brings this system. Okay, so why I needed this to be, is it sitting on top? Okay, it will sit on top once it starts there. You see here it's sitting right on top, right there, and also for these, except for the edge ones. But for the edge ones, it needs to sit on this one. So when you train this, it will sit on top like this. There, there, it's sitting on top. So why I needed this one to be 150 is so that I can have this space here. You see it, this one here, because all of the water will be dropping on the smaller one, and so this one has to be inside, this one has to be above. So in order for me to create this distance, I made it 150. This one I can use 100 like this. I'll do the same thing. I'll choose steel member, steel purlin. It asks me to pick two trusses. I'll pick that one and the one there at the end, and then it gives me a preview here. And then for this one, I'll choose also UPFC, but I'll use the smallest one, the 100 and 10. If you like, you can use angles, but I will use the PFC. I'll select OK, and then so you see, I have that small distance there. You see there, meaning my roofing sheet for this one will sit on top, and then this other one will sit below, so that we can prevent water ingress in this area. Uh-huh. So guys, this ends today's video. I do not know if you've got any questions. It's still recording. Yeah, it is. If you've got any questions, you can let me know. Control S. So we've done most of the modeling today. We've inserted the floors, the trusses, the canopy, the purlins. Tomorrow we are going to add the loading, the combinations, and then we'll run an analysis.
Okay, I got a question.
Okay.
What's the maximum like distance between two columns? like where you need to put the secondary beam.
Okay, that's a
I
very
don't
good
know if you
question.
get.
Yeah, I do. It's a very good question. So, to begin with, you need to, the first thing that you need to factor into, that you need to think of is the material. If you're going to be using concrete, then you need to have shorter spans. From primary to primary, I would recommend not, according to the BS, could be different, but for me personally, I use 3.5. And also because
Mhm.
when I'm talking about maybe 200 by 400, 200 wide, 400 deep columns. But then this is for like a 200 by 400 column also and a 200 by 400 beam. If I can increase my column to be like a 400 by 400 column, it can hold something like a 400 by 600 or 400 by 800 deep beam. And then it could span for, I could even span it for like 6 or 7 meters. Why? Because it's deep. It's the 800 depth and the 400 width. It eh, there's a problem with the network just went. Will it be able to reconnect? Okay, okay, we're back. The network got disconnected there for a minute, but thankfully we are back online. So,
All
who,
right.
Mukubesa, you're the one that asked that question, right?
Yes, I'm done last.
Okay, so for my primary beams, it would depend on the cross section. The larger and the deeper, the more that it can span at longer distances. The smaller the section, the shorter the span. That's a general rule of thumb. Of course, you need to calculate the deflection and the bending according to also the end-to-end supports. If you've got like a simply supported beam where it's supported on one side and the other, then 3.5 would be good. If you've got like a cantilever type of situation, then obviously it would have to be shorter, right? And unless if you're an extremely ambitious architect. But
Okay, okay, understand.
yeah, so hopefully that answers your question.
Yes, it does.
Okay. Uh, concrete cover. For foundations, it's usually advised not more, not less than 30. Yeah, you can for slabs. Yeah, you can. If it's a foundation slab, you can make it 30. But if it is suspended, you can make it 25. Paul, in fact, Paul will be the one to answer this question. Paul, answer this question. What is the concrete cover for elements in the substructure and superstructure? For those spacer blocks. Yeah, Paul, can you hear me?
Hello?
Can you hear me?
Yes, I can hear you now.
So if we're designing those foundations or columns or beams, those great beams, what is the
Yes,
recommended spacer or the concrete cover?
it's 50.
Yeah, it says
It's
50.
50.
50 for foundations. And for superstructure, for anything above, once you leave the foundation, what do you recommend? Okay, probably didn't hear me there, but 50 is yeah, it's correct according to the beams. Yeah,
For the beams, you mean for the beams and the columns? Isn't it
in,
like 25 is 80?
for the foundation, because it will be prone to a lot of underground elements like water and what is it, sulfates, salts that can attack the steel. So you need to make sure that the cover is not less than 50. But the more that you go up, the more that you can reduce the net, you can reduce the cover. I don't know if there's another question. We can end the session so that the video is not too long. Yeah, okay.
Hello?
Yes, Paul, you can go ahead and ask.
Okay. Mr. Since I wasn't here on the first day, and yes, tomorrow we're going to run the analysis. So I wanted to find out because I don't know what type of foundation we are using, and on the design, I can just see the concrete columns, these
Okay,
two columns.
since this is just a two-story building, we will use isolated part foundations, those bases. If it was a
Okay.
multi-story, we would have considered a raft foundation or piles. But since it's just a two-story and the purpose is just for a classroom block, so we'll use isolated pad foundations, the bases, and then
Okay. So we are going to add the parts tomorrow.
yes, because you can only design the foundation after the loading. Otherwise, because the foundations have to overcome the loading. So we need to run the analysis, and then when everything is okay, it will determine the loading that will be going to the bases, and then we'll design the bases. We cannot do it before. Hello? Paul, hopefully that answers the question. Okay, guys, if there are no further questions, we'll call it a night.
Okay.
Oh, okay, go ahead.
So, Mr. Shul.
Yeah.
Okay. So in this case, we already know what the soil bearing capacity is.
Yes, we estimated as 150, but that's a very good question. If we
Okay.
needed to carry out soil investigations, in fact, extremely important, before we can design any foundations, we need to know the type of soil. We carry out a soil penetration test or the dynamic cone penetration. Yeah, we carry out geotechnical investigations, and then we can be able to design the the foundation. But that's an extremely important question and contribution also. In order to design foundations, you need to know the bearing capacities also, and also and the layers also. Yeah.
Okay. Thank you.
All right. Thank you guys. Thank you so much for showing up. I'll upload the video either at the end of either at midnight or tomorrow morning. Thank you. Bye.